Biologists have understood for a long time that song is kind of a special behavior in songbirds. It's learned in a manner that has a lot of similarities to how humans learn speech. For me, the behavior has always been really the fun part and interesting part of working with birds, and I'm constantly impressed with how smart they are in terms of their ability to control their vocalizations. The song has different characteristics just as human speech does. Birds produce these individual sounds that we call syllables, kind of analogous to the syllables of speech. And each of those has a distinctive pitch and timbre to it. And then they organize those syllables into sequences which are learned. So the birds will sing something that's a little bit better or worse, and in some fashion, sort of by trial and error, gradually figure out how to make sounds that are closer and closer matched to this tutor song to which they've been exposed. That kind of variation that's present, you have to vary what you're doing to get better over time. You need to try something slightly different if you're off to optimize your performance. In songbirds, this turns out to be dependent on a circuit. It's a basal ganglia circuit. Now in humans, the basal ganglia are understood to be involved in motor control. They're also a seat of many different disorders. For example, Parkinson's disease and Huntington's disease are two diseases that principally involve the basal ganglia. And interestingly, those diseases include a component that could be characterized as abnormalities of movement variability. Parkinson's disease is associated with a deficit in movement variability, whereas Huntington's has uncontrolled chorea, or uncontrolled movements that are excessive. And so we think it's probably no accident that the same circuit that's performing a function in introducing variability in birds might also be a circuit that, when it goes awry, contributes to abnormalities in movement variability.